land system dynamics in the context of migration and armed conflict using mainly Earth observations and spatial analysis. He's specifically interested in the Middle East and has been doing research primarily on Israel and Palestine, Iraq and Syria. And today, Lina will tell us more about her ongoing research about the destruction of Gaza using satellite images. Please join me in welcoming Lina.
Thank you very much for having me. Right, we're going to talk about how we can monitor the destruction of Gaza from space. And this is related, I mean, this is not the main research I do. This is something that I've been doing on the side since 6 months ago. But I do conflict remote sensing, and I think I'm one of the few people at Lund University who focuses on armed conflicts and remote sensing. And I have been doing this for quite some time, and it actually started in Palestine with my master thesis, where I did a minor field study funded by SIDA to study the accessibility to healthcare in the West Bank. So that's a picture of my thesis up there, and I spent 3 months in Bethlehem at the Applied Research Institute, Jerusalem, to build a model of the road network. I didn't use a lot of satellite images then. I used it a little bit to compare and see where the roads were going, and just see where I had been traveling that day. But after that, I've been working with remote sensing and satellite images more and more. And I would say that I do something, like my work is at the intersection between physical geography and Middle Eastern studies. So I also have some background in Middle Eastern studies, combining these two fields. And I've been studying, as Rola said, like war and land use in Iraq and Syria, climate migration and conflict and vegetation fires more recently. So that's a brief overview of what I've been doing. I was debating whether I should talk about the remote sensing basics here. Maybe not like the most interesting part, but I think there are some things you should know. What I mean when I say remote sensing. And remote sensing is essentially the studying something from a distance. So you're not interacting closely with what you're studying. That's remote sensing. Usually people think of satellite images or aerial photos or even drone imagery when you talk about remote sensing, or Earth observation as we sometimes call it. But what we do is we measure light or electromagnetic energy, and the Earth reflects light that comes from the sun. And then we measure it with sensors that are sitting on satellites. So like cameras up in the sky taking pictures of the kind of light that we can see, the blue, red, and green, but also the kind of light that we cannot see, which helps us get information about other things like vegetation. And that's where, I mean, that's the idea of different wavelengths. They give us different types of information. So we measure light in different wavelengths. So it doesn't get more physics than this in this lecture, don't worry. There are many different usages for remote sensing. It has been used for weather observation, and the image behind me here is actually one of the first images, the one to the right. It's one of the first images taken by a satellite of Earth, and it was taken in, I think, 1971. And it's a weather satellite, so it looks at like clouds and air masses moving. So not really useful for this kind of remote sensing that we're going to talk about today, but still interesting to know how long we have been taking photos like this. It can be used to monitor pollution. It can be used to monitor extractive activities like this. It's hard to see here, but this is a screenshot from SkyTruth, mountaintop mining, identifying mines. Mountaintops using remote sensing. You can also study vegetation, land use patterns. What I'm showing up there is Global Forest Watch, where you can see deforestation, areas with trees that have fewer trees as you move along, or maybe increasing trees, which has also been used, I think, to monitor deforestation in the Amazon, for example. And also forest fires. I mean, there are lots of uses beyond studying conflict areas. The thing with conflict areas is that it's usually hard to go there as a researcher. It's usually, there's usually a lot of information coming from different sites, which can be biased. So with satellite images, we can provide some sort of third option or another option for information. It's not perfect though, but I wanted to talk about how satellite images have been used in international law applications or human rights studies or verification of human rights violations, because it's being increasingly used for that, which is interesting. It's kind of a new source of information in the legal field, and I understand that usually people working in these areas are not satellite remote sensing specialists. They don't really know these things so well. But there are attempts to bridge this gap and provide training to people working in international law, for example, to understand satellite images and the potential it has as a source of evidence. It's also being used by human rights organizations. Here's an image from Human Rights Watch website. You can see that the resolution of the images isn't that great, so you can't really read things, but you can maybe recognize the Human Rights Watch logo, where they use satellite images to confirm reports of things happening. It has also, the first time satellite images were used in the International Criminal Court was in the Srebrenica trials. So where, there was a genocide trial where Bosnian Serb army were found guilty of genocide for mass executions of Bosnian Muslim men and boys. So, and that was, I think the trial was in 2004, so it was quite a while back. But since then it has been used in these kind of trials. Also, there was an interesting story about where Amnesty International, they had a deadly cargo investigation, they called it, where they used satellite images to track where the fuel that was used for the aircraft that bombed refugee camps, where it came from, and they were able to identify the companies that were providing the fuels, which eventually led to some of the companies withdrawing from Myanmar, actually. So it has potential to change things if you use it in the right way. And I also want to say that it's mainly for corroborating evidence. So satellite images alone cannot really tell the story of what happened, but together with reports, eyewitnesses reports, and different things, you can put it all together and get a more complete picture, hopefully. It's also important to remember that the kind of satellite images that can be used for these applications are generally high resolution. You need a high resolution. I will show you some images that sort of shows how much you can see with a certain resolution. And there are some other things to consider and worth noting. So one thing is the timing of images. So when you see an image, if you don't know when it was taken, you don't really know, you can't really say much. You need to know when it was taken to use, if you want to use it to corroborate something. But you also need to know the timing of images if you're comparing something before and after. Is it before during the same month of the year before, or is it just a few days before something happened and then a few days after? It makes a big difference because the vegetation changes throughout the year. So it might look like there has been a lot of changes, but it's only the natural changes of the landscape. So these kind of things are important to be aware of and think about. Also, if the image needs to be processed, some images needs to be calibrated. Some people don't know this, so they just use it as it is and compare things, and it doesn't really work. So this is why I think it's important that you know what you're doing when you're working with satellite images. You need to know the source, and you need to know if different kind of sensors images can be compared, for example. that's not always the case. You need to know the resolution, so like the pixel sizes, and they really decide what you can see and what you cannot see. And then we have commercial high-resolution imagery providers, but they have been found to restrict images from, for example, Gaza. So, for example, these high-resolution planet images that are actually shown here, they've been used a lot in Ukraine, monitoring war crimes and so on. But in Gaza they were restricted after the New York Times published an article about the movement of Israeli troops in Gaza. So after that was published, suddenly there were no images available anymore. So that's worth considering, that the high-resolution images that we need to be able to see things in detail, they are owned by companies who can make decisions about restricting usage. There's also the issue of deepfake geography. I mean, we know that images and videos can be manipulated, and so can satellite images. So, and that's an increasing risk that this will be used by different actors to manipulate stories, and also making people uncertain about whether satellite images do provide an accurate image or a reliable source of information. Yeah, but let's talk about the destruction in Gaza. And I'm really, it looks better on my computer screen, but I hope you can see some things. So this is an image from November last year, and it's not what it would look like if you just took a normal photo. It's enhanced in different ways, so it's more green than it should be. So the green areas are obviously lots of agricultural lands. We have these gray areas, which are built-up areas, houses, some houses obviously damaged, destroyed. And then we have these orange dots in different parts of the image, with a lot of smoke coming from them, and that's obviously fires that can be detected. And I think it's interesting. I looked at another source of data which identifies fires, looking at like differences in temperature, and it actually, for the same day, it identified 3 fires in the same area. So some of these fires were hot enough to be detected by a satellite sensor, which usually is used to study like wildfires, big ones. But I think, I mean, what we see, like the destruction we see in Gaza didn't start after October 7th last year. It started way like longer back. And the kind of images that I show, the last one and this one, are from Sentinel. It's from the European Space Agency, and they have a resolution of 10 meters. So every pixel is 10 meters. So anything smaller than 10 meters will be impossible to see, but things that are like 10 meters and bigger are like, that we can actually see if we zoom in. What I've always been like interested in, or sort of, what do you say, like found interesting and shown to people even before this past 6 months, is the difference in how the landscape looks between Gaza, which is this area, I think you should recognize it by now, and the Israeli side, where it looks completely different. I mean, it looks like any like southern European area, and then you have this place where you have such dense built-up areas and some agricultural land, because there is a limit to how much they can import, so they need to have agricultural land. And probably, I think, like most of the area of the Gaza Strip is used in some way. I mean, there isn't any unused land there. It's either where people are living, moving around, roads, agriculture, greenhouses, like it's really dense. And I think it shows so well because this image doesn't have any lines showing any borders, but you can clearly see the border here with Egypt, you can see the border with Israel, and it's just so clear. But because I said I wouldn't talk a lot, I told Rola I didn't have a lot to say, but then I realized I have a lot of things to say and show. So we're going to move into what happened in the past 6 months. And I said before that it's good to compare, to know what you're comparing. So this image is also Sentinel. It's from, the one to the left is from 1st of March 2023, and then 5th of March 2024. And it's kind of hard to see things, and if you zoom in more, it doesn't really give you, because then it gets a bit grainy. But this is Al-Shaqti Gaza area in the northern part of the strip. And maybe, you don't see things, if you're not trained to look at satellite images, you don't really see things like from the start maybe. But if you are trained and you take some time and really look at it, and maybe also don't look at a projector screen, but actually on a computer screen with good resolution, then you can start to see some things. But I've highlighted some things that I've seen when looking at these images. And this is the first thing. So 2023, we don't have this kind of road-like structure there. In 2024 we do, and it's kind of wide, kind of big thing. I'm not going to be able to tell you what it is, but like these are the things I notice. Then we have this area up here, kind of hard to see here, but it shows, like you can see, if you look closely, you can see that there are houses are missing. It looks a bit less like, less sharp edges. Like you have sharper edges, you can see houses in this one, but on that side, in 2024, there's a big difference. It looks a bit grayer, a bit more mixed up. And I think these two images are very clear. They're taken on a very clear day, so I don't think it's atmospheric interference. It's something that has happened here, which we know. Then we have this area here. It used to be quite green last year, quite a lot of green areas, agricultural fields. That has gone missing a bit, and there, you have the same kind of change from more clear structures to what looks more like a mixed, mess of things. Probably a lot of rubble, damaged buildings. Also here, I think it's really hard to see for you, but I saw it before. There are some changes there as well. And here I would say, maybe I can use so here I was thinking about these things that look like the roads have been widened and buildings have been removed. But what I'm trying to show is that it's kind of hard to see on these images that are freely available. That's where we need high resolution imagery. But if that's not available, then it's really hard to work around it. Maybe you've seen these kind of maps in the past 6 months. They've been in different news reports, both in Sweden and in the US, everywhere. They've used these maps from the Decentralized Damage Mapping Group, which is a group that I've joined. They invited me in November probably, so I've joined their meetings. We meet once a week, talk about what's going on, assessments, ways of solving problems that we have. It's quite technical, it's quite focused on what we can see, and right now very much focused on Gaza, but also interested in other areas in crisis. And it doesn't use like this visual inspection of images, it uses something called synthetic aperture radar, which, in a very simple description, it measures the distance between the satellite or the sensor and the object. And if there are changes in this difference, and if that is happening in a place where there has been a building before, then that suggests that something has been damaged. So it looks at how this electromagnetic radiation bounces off of buildings. And by using that, they've been able to estimate how much has been damaged. And it's quite a lot. In the beginning, in October, it wasn't so much. You had more up in the northern parts of Gaza. By November, you had quite a large area destroyed, mostly in the northern parts, and a few weeks ago the latest assessment came and it was, all over the area. I guess it's obvious that the red areas are the areas that have been damaged. And it doesn't mean that they are completely damaged, it can be partly damaged also, because that's something that this method cannot distinguish between. But it does say something of the destruction of Gaza and the fact that people don't have anywhere to go, nowhere to live. And maybe you've also heard of UNOSAT, which is the United Nations satellite group, which also come out with assessments. And they came out with one recently that looks like that. They have a lot of information in their maps, so it's kind of hard to see. But they estimated about 30% of the buildings had been damaged since 7th of October. And we have been discussing this in the group, and we're interested in comparing these because they're using different approaches. So I think the UNOSAT approach is more looking at satellite images, trying to identify damaged buildings, and then they get less. But you can see the pattern of destruction. The red areas in the UNOSAT map are like they show a similar pattern. It's just not the same amount of buildings that have been destroyed. And we think that, one reason for this is that when the approach of the DDMG group is, it allows you also to see from the side, like to measure radiation that is bouncing from the side of buildings, whereas that approach is like from the top down only, so you miss a lot of damage because of that. Maybe. We're looking into it. Yeah.
On the left maps, the grey areas more like distinct than the buildings on the right one. Is there like a certain reason for that? It looks like they are in clusters, like a big cluster of grey. Is that the buildings?
Yeah, these grey areas are the buildings from the Microsoft building footprint. And I think it's combined with the OpenStreetMap also, but none of these data sets are complete because there wasn't any complete data for where the buildings are in Gaza. I know the OpenStreetMap humanitarian mapping team is working on this to provide a more complete data set. But there are different assessments coming out all the time. Right, so if we look a little bit at agriculture, and this is the area where I do most of my work, I look at how agriculture changes in conflict areas. And here, right, I've written it there, this is a false color composite. It just means that the color that we can see here is not how it would look if we were in an airplane looking down on the area. We have enhanced the infrared wavelengths here, so we see that the red areas are areas where you have a lot of vegetation that would look green to us. But it's a way to show where we have vegetation cover, essentially. And this is in the northern part, it's Beit Hanun. And I decided to look at March from 2020 until 2024 to compare what it has looked like in the past 5 years, or past 4 years. And I think it's an interesting pattern because you have a similar pattern of some of these agricultural fields being red, like lots of vegetation on them. Some don't have vegetation in that sense. They might have a different type of vegetation or something, or they're harvested early before March, not sure. But the pattern looks similar. You can also see some clouds on the March 2022 image up there. So that looks a bit weird, but that's just clouds. But the patterns look similar until you get to 2024, because here we see a lot of red fields, a lot of vegetation. And then you might think, well, there's a lot of agriculture going on here. But I don't think that's the case, because a lot of people have left this area. This is what happens when people abandon land. Maybe it was sown, but nobody's managing it, so it isn't harvested. Weeds are not managed, so maybe it's just a lot of weeds. It's not crops that can be used for anything, probably. So sometimes you think of destruction as kind of bombing, shelling, that kind of thing, but it's also this forced land abandonment that leads to these unused areas. Also, you see this road-like structure here as well, that isn't in the previous images. Yes?
What is the yellowish, whitish
This thing?
thing? Yeah, because it's quite different in the different pictures too.
So this is the border area. I think this is bare soil, sand. Is what I think. I haven't double checked, but I think that's what it is. So it has a very bright reflection. Yeah. There's also a way to measure light emissions by looking at nighttime lights. So how much light is emitted during the nighttime in these areas. And I thought it was interesting to look at it. We know that that Israel has controlled how much, the power in Gaza, and they also, after October 7th, they said there will be no more power, we will cut it. And that shows in this image that's actually more or less what happened, because October 6th you have quite a lot of, the brighter the pixel, the more light there is. And you have a lot of light in the Gaza Strip, you have light areas on the Israeli side in different villages and towns. And then just 5 days later, Gaza looks more or less dark. There are some light points in different parts, but there's a really strong difference. But the areas outside, they look the same. They have the same amount of light, which tells me that this is not because there are some clouds interfering or some other calibration issues, probably, but rather that this is the effect of the war. And even if you look at, if you go further in time, if you look at more recent images, you can see that it's still dark. It's not. Yes.
It kind of looks like there are light pictures in the sea as well. Is it because of reflection from?
Yeah, exactly. I'm not sure. This is probably some small issues or calibration issues, and some, because these data you need to really compare them in a quantitative way. You need to pre-process and make sure that they are corrected and calibrated so that you can compare them. Now I'm just putting them next to each other, but they're not. It's not perfect. You don't have those kind of light sources in the sea, I think. Good point. Okay. So many excited about this like satellite images. I've been talking to a lot of national news outlets, and like we sometimes describe it as an objective source of information. It can be, but we who interpret are not always objective, and you have to know a lot of things when you look at these things. And like I mentioned, we also have the problem of manipulating images. So it has potential, it can be useful, it should be used because it's another information source. But after working on this, I'm still kind of wondering like what kind of information is needed to stop this from happening. Because yeah, so far, like this is not enough, obviously. Thank you for listening.
Thank you.
We still have some time left for questions, so if anyone has a question.
I can ask
Yeah?
a question. Thank you, Lina. And this is really very interesting, even though it makes me sad, you know, looking at these pictures, especially like the last one when all lights are gone,
Yeah.
basically. But on the other side, they are still the same. And I think we're talking about distance maybe less than 2 kilometers.